Hello, everybody. How was the day so far? Good? So it's the last session before party. Challenging one. So today's topic is dependency injection in .NET. Why it's called Revisit is because I think most of us are aware of what is dependency injection in .NET particularly. And revisiting, I mean that we might be able to go back to the basics. And why I mean, and what was the motivation behind this talk is, actually I was looking through one of the latest code bases in one of the projects. And still I do see a lot of anti-patterns in the code base, a lot of things that should be done differently in terms of dependency injection, the proper application of the dependency injection, and that I thought that it's worth to revisiting it once again. So my name is Valdis Iljuconoks, and I'm a software architect in a Norwegian-based company. I used to be a developer, but I converted myself to the software architect. I am a Microsoft MEP and also a very similar program for the company called Episeller. However, I'm software architect, but I'm still, doing some coding. So, anybody knows why we need a dependency injection? What is the purpose? Okay, I can warm up the audience. There's a free giveaway book called Dependency Injection in .NET. So, what is the reason? Decoupling. Yes. Here you go. Take it. That's yours. So, yep. The main reason why we actually need a dependency injection is, this decoupling, when it bites us, is that we have to work with the legacy code. It's not understandable. It's like a mess. It can't be readable. It's, some big ball of mud. Anybody knows the context of this picture? No? Neither do I. But it looks really great. It really represents this feeling of working with the legacy code. Like, what the? So, today's plan is to revisit the patterns, what we are using in dependency injection. Then, of course, we have to revisit the other side of the patterns, the anti-patterns. And we see what kind of anti-patterns we do have here. And also, I'll try to explain and guide through my experience with that dependency injection during my open source project development. So the definition of the dependency injection is actually pretty simple. First of all, we have to start with the dependency. What is dependency? Sometimes we think that dependency is, I need some service, and that service needs to be somehow given to me. But the dependency is not only the service. It's not some kind of interface or class. It even could be an integer. It could be a string. It could be some context-sensitive information that's given by you as a service author. So definition of the dependency injection is that it's a set of the principles and patterns that enables this loose coupling or decoupling of the components of the modules. And here the patterns and principles means that it's not the ultimate goal that every single code base has to follow the dependency injection principles and patterns. For them, it's we have to strive to that. We have to aim for that goal, but that's not the ultimate goal. Sometimes it doesn't even make sense to apply dependency injection. Might be. Also, the dependency injection is known by the names as object composition, or sometimes you may, reading the documentation, you might see a term called inversion of control. And here the term inversion of control is the key factors here that you as a component author, you actually don't care how you get those dependencies. It's not your business, right? You have to ask somebody, if you want to work with my component, if you want to get that functionality out of this component, you have to give me those required dependencies. Where you get them, what is the lifetime of these dependencies of those services? Me as a component, I don't care. If you want to work with me, you just have to give me. And this is this inversion of control. The component does not control the lifetime of the components and the dependencies, but it's given by somebody else. Usually it's container, maybe it's somebody else. So I really hope that most of us are familiar with solid principles. And dependency injection in particular is kind of, fueling these principles. That dependency injection really is about inversion of dependencies, about open-close principle, about the list code substitution principle. That it's really applying the dependency injection, those solid principles just, flow through and come together. So let's take a look at the patterns. What kind of patterns we do have? It's actually really simple. Most of those you probably know them already. Maybe not by the name, but definitely by the code. So the first one is called the constructor injection, and this is the most commonly used one. This is when you're declaring the component. You have a constructor of that component. You're basically asking in a constructor arguments, I need those external dependencies. Either those are interfaces or abstract classes or just the classes or strings or maybe some, simple values. But those are my dependencies. I just need them in order to work and provide the value for this component. In the code, how it looks, so what I did is I created a sample application. It's called the chat system, which is basically a simulation of the chatting system in console application. It's really like a simulation only. In the constructor injection pattern, can you read? Yeah. In the constructor injection pattern, it's really, really easy. If you take a look at even the Visual Studio tells you what kind of dependencies a particular component needs. You just can't create an instance of that component if you don't supply those dependencies, right? So it's really easy and straightforward. In this particular case, what we are doing is, there's a chat service component that needs one party who is chatting, another party who is chatting, and the channel where the chat happens. And all those three dependencies has to be provided as a constructor injections. The other pattern is called the property injection. The properties here is just simple .NET properties with gets and sets and maybe default values if needed. In the code, how it looks is that, for instance, here we do have kind of another copy of the same channel. And in this case, we can see that the channel from the constructor injection requires only two dependencies, one party and another party. And say that this component does not need a channel by default. You can give me one party, another party. In this case, it's a husband talking to wife. And the channel is omitted here. So I can, as a consumer of the service, I can't give directly the channel, but I can give it through the property. This C# construction that I'm creating a new component and then giving the property values at the same time. This is called the property injection. How they are different between the constructor injection and property injection is so that the property injection is used in the cases when you do have so-called local default. So in that component, I do have some default implementation of the channel. We can take a look at what it is. So in this case, it's still the same console channel. It's outputting all the messages that those parties are talking to each other out to the console. So it means that every time I will create this service instance, by default, it will be a console channel. If I need to override it and set to any other channels at that particular use case or that particular system, I can just provide as a property value. In this case, all the messages that they are chatting between each other are going to the dev null. So basically, they're thrown out. But it's the case how you can override the functionality of the component. The next pattern is called the method injection, which is kind of very similar to the constructor injection. But the case here is that you're providing the dependencies at that moment when you're invoking the method. So it might be that the constructor is pretty simple. It's empty. You can just new up your component. And at that time, when you are invoking the method, when you're trying to work with the component in the method requires some dependencies. So that's a method in injection. I think I do have. No, I don't have sample. And the last one is kind of pretty slippery pattern, but still it's considered as a pattern. It's called the ambient context. And here the ambient context is something really similar to the kind of statics. Mostly it's used in the cases when you have some dependency that should be accessible everywhere. So not to polluting the APIs that you need to pass the dependency over and over, from the top to the down and back. It's kind of, collapsed and encapsulated into the component that's always accessible, usually through the statics. So the obvious sample of the ambient context, for instance, in .NET Framework is thread.ui culture. So it's accessible everywhere, and you can set it, you can get it, and basically do stuff with that. The same, for instance, datetime. .utc now or just a now. So those are the ambient contexts. And for instance, in this sample application, what we have here is, I just implemented my own time provider, which is sometimes a really good idea if you want to unit test the applications that depends on the time. So in this case, I always have access to this time provider. And the funny thing about the time providers is that if you have your own sort of time machine, the funny thing you can do there is if you're writing the unit test, which test the times, etc., you can actually build the really rich APIs around that time. You can fast forward time by X minutes, or rewind it back, or freeze the time for some minutes, or do some fancy stuff with the time. So it's sometimes worse to implement your own. So looking at those 4 patterns, and that's it. Those are the basic building blocks for the dependency injection. You might be asking yourself, okay, I know the 4 patterns of dependency injection. What is the case when I need to use them? What is the application of each of the pattern? So in this case, let me just guide you through the kind of decision tree here. If we start from the very top, when you do have a dependency, the first question you have to ask yourself is, do you need a dependency or do you have a dependency? If you need a dependency, then it will go down to the other patterns. But if you already have a dependency and you have to supply the dependency to somebody else, then you land on the method injection. So you somehow get the dependency. I don't know from where, just somebody gave you that dependency. And to invoke that method, you're just passing that dependency further to the method. And then later on, if you actually need a dependency from somewhere, then actually the next question is what kind of dependency it is. Is it a cross-cutting concern, or it's just a dependency that needs to your workings of the component? And if you follow by no branches of those decisions, so if you're asking yourself, okay, what kind of dependency it is, if it's not a cross-cutting concern dependency. And then the next question is, which is the this figure. You're asking yourself, do I have a local default for that dependency? Is there something that I can, assume by myself that I might be not getting that dependency, but I do have my own implementation, or the pattern called the local default? If you do have, then you go for now. If you don't have that local default, you go for the constructor injection. So that's kind of straightforward way through this decision tree. I need a dependency. It's not cross-cutting concern. I don't have a local default. I just have to demand the dependency through the constructor. If that's a not cross-cutting concern dependency, but I do have a local default, then you go for the property injection. So that's kind of, for the consumers of your component, it's more like an optional. They might be overriding with some junk, or maybe go just with the default implementation. And then if we step back to the cross-cutting concern decision, if actually that is a cross-cutting concern dependency, like, I don't know, some caching, validation, logging, auditing, whatever, take any cross-cutting concern. Then the next question is, do you really need an answer from that dependency? Do you need to get something out from that dependency? So if you need to get out from that dependency, but you don't have a local default, then you are implementing the ambient context. It means that it's accessible everywhere, from any layer, from any component, from any onion slice, whatever you call it. I can always ask that dependency. I can always go to the static property or static method, whatever, and I will get back the value that I need. Time provider, current culture, all that stuff. Sometimes HTTP context as well. And the last one is, if that's a cross-cutting concern, for instance, caching or validation, but you don't need the answer from that. You just need to write some audit log to the database or do some validation that throws the exception, etc. Then you're implementing something called the interceptors. The pattern is called the interception. So we'll take a look at that as well. So basically, that's a decision tree as a cheat sheet for you, which pattern to use in which case. But it's kind of, from the decision tree, it looks that the constructor injection, the least to be chosen one, but it's actually the most used one. Because usually, if you're building the component, you will need a dependency. You don't have a local default. You will be asking somebody to provide that dependency. Otherwise, you can't work, and you can't provide that business value for the consumers. So those were the patterns. What about anti-patterns? There's actually kind of a lot of them. I picked one of the most common ones. The very first is called control freak. What is the control freak? In the code, it looks really funny. If we go to the anti-patterns and let's say the control freak demo. So it's the same chat service. It requires two dependencies, one party, another party, and you can invoke some method on that particular service. If you take a look at the inside, what's going on in that component, you can see that there's a bunch of stuff going on. First of all, that in general the constructors are kind of a ceremony. It's an implementation detail that's basically most of the time capturing incoming dependencies, saving to the fields, and that's probably it. And then on the invocation of the method of the component, those dependencies are used and taken into account. But in this particular case, what a component or this chat service is doing, it basically captures the incoming dependencies, one party, another party, and then that guy needs to figure out what kind of channel should I be using. There is no default, local default, so it's not newing up any of the service, any of the chat channels. but it's actually going to the configuration file. If we take a look at the configuration file here, it's quite straightforward configuration file, but basically what it means is that the component itself is taking decision what kind of channel it will be used. So probably you have seen these kind of services that you configure something in web config files or application config files, and then some stuff happens. Why it's bad is because imagine how I would be testing this particular service. So I would like to know what kind of messages were outputted to the channel. So what I would need to do probably is, if that's supported, I would need to add a new type of channels in this particular switch statement to be supported. So that's already violating open-close principle. So in order to add or test this component, I need to change the source code of the component. And also I'll need to somehow tweak the configuration files for maybe a bunch of unit tests to be using in-memory channel output, or for the other bunch of unit tests to be using totally different channel. So it's kind of really clumsy, and particularly this component is closed. It's not unit testable. It's not easy changeable. And I've seen these kind of codes a lot, actually. So the question is, what is the refactorings here? What kind of design patterns we can apply here? And before I jump to the implementation details of the refactoring, we actually have to revisit another pattern, something called the composition root. Who knows what is composition root? Few hands? Cool. So, composition root, what is it? We can take, for instance, a layered architecture. We have the pretty similar drawings area. We have a UI, we have a business layer, we have a data access layer, blah, blah. And there is a small, tiny place in the application who is responsible for so-called composing the object graph, the dependency graph. For instance, incoming HTTP request to the MEC application. In this particular case, the composition root here is something called a controller factory. This is the guy who will be figuring out from the incoming HTTP request what kind of controller to be invoked, which also means that all the dependencies that controller requires, or that service dependencies that that controller requires, or those components, that whole graph should be built up. And that's the place where the composition root is taking the place. We can take another architecture style. We can take an onion architecture, for instance. The same application here. You have a small, tiny place in the application and the system who is responsible for building up the whole object graph. The same for any other architecture styles. So usually composition root is placed really, really close to the application entry point. Depending on the framework, it might be different places. If you're writing a console application or web job, which is basically the same console application, if you're building some batch jobs or whatever, it most probably will be something really close to the main function. For the web applications, you might have something iController factory, or something maybe in even global ASACs, etc., etc. So this is pretty close to the outer edge of the application, something that's before continuing further. There's a composition root that creates all the dependencies, that creates all the objects needed, and then pass through. Why it's so is because once you get into the let's say a business object layer, if you get into the component, the thing that should be avoided there is something that called service locator, that we will touch briefly. That you're still looking for the dependencies. You're still asking precisely and explicitly, I need those two services in order to work further. So that should be avoided, and all the stuff that's composition root related should be moved out to the services, out to the composition root. So that's the guy who is basically building up the whole object graph and then purely invoking all the other methods further. So for instance, in this particular case, we have this freaked service that's basically taking a decision on what kind of output channel will be used in this console channel, in this console service. And the refactoring here could be so that actually what we can do is, first of all, it's might be not really nice looking code either, but the decision of what kind of channel will be used is moved out to the component itself. The component actually is asking, if you would like to invoke my message, if you would like to chat between the husband and wife, you actually have to provide the channel for me. So it means that decision here about what kind of channel will be used is taken off to the service. What it gives me is that I can write easily unit tests now. I can create in-memory channel that I can intercept and read on very easily. And I can pass just that in, and I can inspect the results after the unit test. And also the further refactoring here could be that the whole channel construction is encapsulated in something called output channel factory, for instance, who's making decision further. But still, it converts this component and makes it really easy to test it. The next anti-pattern is something called bastard injections. And bastard injections are also pretty similar to the control freak. But the case here is that probably you have seen these kind of constructors. That, first of all, I created a constructor with 2 arguments requiring one party, another party. And probably the channel construction was inside the constructor of this service, maybe by the configuration or just was newing up, whatever. And then somebody told, we have to do unit testing. And then probably the author of the component, oh, well, I can create an overload of the constructor, and you can pass me in this service if you this channel if you need. But by default, I'll create the console channel output. So now the question is which kind of constructors I should use. And it looks basically like the author didn't make up his mind. There's multiple possibilities how you can create this component. So the refactoring here is pretty simple. You just get rid of the first constructor. It's basically not needed. You have to supply this dependency. If you would like to have this possibility to override and change the output channel, you can refactor that to the property injection. By default, I'm using the console application, the console output channel in this application. But if you want to do some other stuff, you can just pass in different channel by the property. So that would be the refactoring here. Next one, what we have is something called constraint constructions. I've seen these kind of anti-patterns a lot, even in the recent code bases. What we have here is, let's say, pretty similar, the same chat service. That's you can configure by the generic parameter here something called message formatters. You can give a type of some kind of formatter that giving in the party who's telling something and the message which that party told in the channel. And you can do some stuff with that message. And this not bastard, but the constraint constructions, the anti-pattern of this particular case is that the service itself is taking a decision how this given dependency will be constructed. Which means that actually the service does not have any clue. Maybe I do have some other dependencies needed for my formatting. Maybe I do need some, calls in the constructor or whatever. This particular case is also pretty closed. So the service can't regulate my constructor. It's basically telling, you have to have a parameter-less constructor, and that's it. And how you get the other dependencies that you need, well, I don't care. That's not my business. Right? So what we can do here is actually the design is a bit awkward in this case. So that it's not a good idea to request dependency of the message formatter as a generic parameter. Because you don't know what that particular formatter or that particular dependency will need in order to construct itself. So you just you just need to request it from the constructor. And somebody should give you the instance of the formatter. And the last one is probably the most well-known. It's something called service locator. Anybody use that? So service locator, I can actually still recognize that service locator in .NET Core, something called iService Provider. It's basically a collection of the services or registrations, so-called, that you can easily ask to that provider. I do need this service, or I do need this abstraction implementation, or I do need those values out of the service locator. And why it's bad is because let's take a look at what's going on in this straightforward sample. Still, we are looking at the same chat service. Looking at the API, I see that the service needs two parties, husband and wife in this case, and nothing else. This is the only constructor that's on top of this service. So APIs, what they're telling me is that you just need to provide one party, another party, and basically you're ready to go. There's nothing else you need to provide me. But looking inside the source code, I can actually see that in order to make a decision what kind of channel will be used, in order to make a decision what kind of message formatter will be used, he's using something called service locator, service collection, iService provider, whatever. Just name as whatever you want. Which means that the APIs actually are lying you. You actually don't know what kind of dependencies that service needs, just looking at the constructor. And there are also a few refactoring cases here. One of the most straightforward is that you're requesting those dependencies from the constructor. Just you need to pass the channel, you need to pass the formatter, you need to pass any other dependencies that's needed for that service. Because, for instance, if I would be launching this application now, I would be getting an exception. Because, for instance, in my case, this service collection implementation, if it tries to resolve the requested implementation of the interface, it will blow up if the registration is not there. So it means that the application compiles, but it doesn't mean that it will run. So it's a really lying APIs. It's not exposing everything that the APIs needs here. So it's called also something Hollywood principle, which means that you just don't ask us. We will call you, which basically means that I don't need to go to the service provider. I don't need to go to the IOC container to ask for the services. You have to give me those services in order for me to work, right? And also a few years ago, there was even an attempt to unify the service locator under a library called a common service locator. And it was pretty funny that the author of the book was also a part of this library, which later on he decided that that was one of the biggest mistakes of him, to promote this service locator pattern. So we do have a few anti-patterns, and those are not the all. There are a lot of other anti-patterns, but these are the most common ones that you might be seeing in the code bases. So then the next question is, okay, I know the patterns, I know the anti-patterns. What is the journey of applying the dependency injection in my code base? So the idea here is that the dependency injection containers, which like structure map, IOC simple injection, all those things out of those things are more like optional. It's not mandatory. Sometimes, talking to developers, if I'm referring to the dependency injection all the time, what's in their minds is, okay, I need to be compliant with some kind of IOC container. That's the dependency injection. Actually, the IOC container is more like an utility for you as a library that helps you compose those objects. But if the components don't follow the dependency injection principles, the IOC container just will be an abstract factory that's building up some services for you. So one of the way, if you're building your own library or if you're building your own framework, whatever, one of the way you can actually go is the so-called pure DI, or also known as a poor man dependency injection, which is basically that you are composing this object graph manually. You're saying, flying through the constructor injection patterns, okay, I need to create this service. That service needs those two dependencies. I need to create those dependencies. If that dependency needs other dependencies, I'm just, following through and going through this object graph. Another way, of course, is to use some kind of IOC container. It will really ease your life, and it has a lot of a rich set of features that could be utilized and used. And actually, there's a lot of IOC containers out there. And to make a decision which one to use, it's basically you need to understand what kind of functionality you will need. And I would start with the very, very simple. Even if you're on the .NET Core, I would start with the Microsoft Extensions dependency injection, which is kind of part of the .NET Core framework. And the cool thing here is that, remember the composition root. That's the small part in application who composes the services, who are creating all the object graph. From the theory, it's the only place where the code is allowed to reference the IOC container APIs. Asking for the services, asking for the dependencies, composing the object graphs, and then proceeding further. If you decide to change the IOC container from one to another, you actually have only one single place to be changed in the application. And the rest of the components, rest of the code base actually are not aware of any IOC containers at all. This is the composition root main goal. It's composing the objects, taking features from the IOC containers, and then all the dependencies are flying further. In the application of the dependency injection, it's really really important to understand those principles that call the RRR, or register, resolve, release. Idea here is that there is a place where all the abstractions are registered against their implementations. So it means that if somebody asks me this interface, I know what kind of implementation I should return, what kind of type I should return. There might be a multiple resolve phases, so to call. Usually registration is done once. So it's your startup class or register services class or some special IOC registries, whatever. And then there's a multiple resolve and release phases. If the incoming request is coming to the application, the dependencies are already registered. So what you are doing, you're actually trying to resolve, okay, what kind of dependencies this controller will need or this service will need. You're asking for the IOC container, or you might be asking for your own implementation. Okay, I need to compose this object, what kind of dependencies it needs. An important part after the request is served is actually to release the resolved dependencies. Because might be so the case that one of the dependency is so-called the leaky dependency, or it should be released explicitly. Maybe holding some, external connections or some disposable dependencies also. So this is a really important thing that everything you resolve, you have to actually release as well. So this is a really kind of a good way to follow. And also, it's really important to understand that each of the dependency might have a different lifetime. So what is the lifetime here is that you might have some utility style dependency, which is needed only to have one instance per application. I don't know, some logging factory or somebody who writes to the file, to the log files. So usually that dependency will be configured as a singleton, which means that once the dependency is created, it's always returned the same instance all the time, because it doesn't make sense to create a new one dependency all the time. And it's important not to mix the dependency lifetimes, because it's really easy to tell that the singleton dependency is depending on the service who is with so-called less lifetime. For instance, either per request, which means every time I will be asking dependency, it will be recreated from the scratch once again. It means that once the singleton dependency will depend on the so-called transient or pre-request dependency, it will be so that that smaller lived dependency will be taken as a singleton. So that will be only one single of that small dependency, just because the singletons are referring to that one. This case is called the captive dependencies. And also some of the IOC containers have a facility to scan through the dependency graph and try to realize that there is such a captive dependency case, that singletons are referring to shorter lived dependencies, and they're kind of giving you a diagnostics information back to the user. But usually that's really easy to fall in, and then funny stuff may start to happen. So what is my experience with the dependency injection is, first of all, of course, when you learn, you make a mistakes, and that's okay. That's the life. One of the mistakes that I did is something called a conforming container. Conforming container is idea that if you are building the library or if you're building the framework, you're building so-called the adapters for each of the IOC container. You do have a adapter for the Unity container. You do have adapter for structure map, for AutoFAT, for any other IOC container. And for instance, if I take a look at my one of the open source libraries called Feature Switch, I see that there is a few IOC container adapters, particularly targeting specific version of the IOC. And if the container changes, I need to keep up with the my adapter, and basically it's a clumsy solution. It's not working. It's something called a conforming container. Idea here how you can basically refactor and drop the dependency on any IOC container at all is something that Jimmy Bogart did in his library called Mediator. You have to give a lambda expression to the mediator how the services will be built up. And as it's the lambda expression that just returns the object, you actually are kind of splitting apart the IOC container infrastructure and your library. You have to give the two lambda expressions, one for the single instance, one for the multiple instances, and that's basically it. And that happens in the composition root. That's the only place where code is allowed to refer to IOC container APIs, and you're just giving those lambda expressions to the library, and library is not even aware of what kind of container was used. It's just using those lambda expressions to get the service instances back. So that was a really great way to cut off the dependencies. Also, most of the time, at some point, it really comes to this something called a constructor over-injection. The case is when you have like zillions of dependencies for constructors. Like you need one dependency, another, third, fourth, whatever. We even can take a look at the sample code from empty .NET Core web application. You know, something called, if you create a new MEC application and checking something called add the user authentication or something, it creates a bunch of the controllers there. One of the controller is called account controller, which already have a bunch of dependencies. And my rule of thumb is that if you need more than 4 dependencies, there is something wrong with the composition of that service. Let's say in this particular case, if we do have an email sender dependency and we do have a SMS sender dependency. What if the client asks, please fax us? We are using fax, please implement the iFax sender service. Most probably I'll just be adding, adding dependency here, another one. So the refactoring here would be that you are kind of grouping together the services and exposing as a separate service. That's a composition of related functionality. You would be asking for, iNotification sender or something like that. And then you can take a decision which channel to be used to send a notification. And also, another error that I made is something called the role interfaces and service locators. And the case here was that, sometimes it's obvious that you need to basically, where is it? In this particular case, the same chat channel, chat service with the 2 dependencies. And inside that chat service, what I'm doing here is I'm first of all trying to resolve the dependency. Sometimes there might be a dependency set already in the code or in the composition root, or in this case there is a service locator that's used for the composing. An idea is that, if this dependency is not set, so I'm just not using that. If it is set, then I'm invoking that dependency. I've seen those code bases, not a lot, but there are cases that this particular ant pattern is applied. So the refactoring here could be that, you can throw out this particular code and you can, this particular fragment, and you can implement something called a null object, which means that dependency is always requested from the either constructor or any other pattern, and it's always given the control to that dependency, which means that if in the cases you don't need to perform this action, the null object will be just passing through. It does nothing. You give me something, I do nothing. Sorry. On the other cases, you might be adding to the service collection something that you really need, right? The actual functionality. So again, it depends on the composition root, what kind of dependencies you are injecting there. That will be the object graph used in the application. So it's really avoidable, this style of coding as well. And this is something called the role interfaces. There is somebody, if there is, you're using that. If you don't need that functionality, you just, adding this so-called a null object, which is just, doing nothing. But in the component itself, you can get rid of this try catch, or if there is something, I'm doing something, and if there is nothing, I'm not doing anything. And also about the abstract factory. The abstract factory is something that really reminds me of the service locator. That abstract factory is built for composing the objects, and you can ask the abstract factory, okay, I need this kind of service, give me the instance of that service. it reminds me the service locator, but the case here is that this is a little bit different. So this is the code for the service locator. And this is the code for the abstract factory. And if we compare them together on the same page, we actually can see the difference. Service locator is able to create any kind of services. You give me something, I will try to give you back. Abstract factory, on the other hand, is able to create only a concrete type of services. And if it's used in the composition route to build up the object graph, to build up the dependencies, it's not actually intended to be as an anti-pattern. So that's the way how the dynamics are working. That I don't know. Somebody asked me this service. I don't know who it is. I'm just asking the abstract factory to create one. Also, from the experience, is a really interesting case for the attributes. For the attributes, it's really interesting from the compilation perspective, is so that if you take a look at the same web application, for instance, I do have an attribute called UberSecure attribute. If I go to this attribute, I can see that this attribute is requiring the dependencies. And usually that's a normal case when I'm implementing the functionality inside the attribute, like authorize attribute or handle error attribute, whatever. But the problem here is that during the compilation time, actually, there is no way I can inject that dependency in the attribute. But I need to perform the task to do something, and that business logic or that functionality is inside that component. So what the Microsoft did is they came up with interesting solution. There is something called a service filter, and then you can give a type of UberSecure attribute. This is the way how you inject the dependencies into the attributes. If we take a look at the service filter source code, which is now open source, so I can show it. It's actually doing straightforward thing. At the time when somebody asks, like MEC pipeline asks, you need to create the instances of those attributes, it's going to the service provider and asking, I need this given type of something. So that's the way how the service attribute constructs the UberSecure attribute, passes in all the dependencies that that attribute needs, and then later on invoke the handle action of that attribute. So it's kind of a smart way how to come over. And one thing that comes into the play using the dependency injection is something that's called aspects or interceptors or decorators, or depending on the case. With these guys, actually, what we can do, we can implement so-called Russian doll model, especially with the decorators and interceptors. The case here is that if I do have some component, it's registered in the IOC container as the component, telling the structure map or any other kind of IOC container, I can actually tell them that, I need to, for instance, in a decorator case, I can actually tell them, if somebody asks me iMessage formatter, I can tell, okay, please decorate all the instances of this iMessage formatter with some other iMessage formatter, which might be doing some other stuff. Idea is that you asking, okay, give me the original message formatter, I will do some stuff, and then I can decide whether I will forward this call to the original format, or I will abandon the call and do some stuff or throw the exception or whatever. So this is the way how you can build from the component the other components into this what called the Matryoshka model. And usually with these guys, there is implementation of all the cross-cutting concerns. It's really actually straightforward to implement the loggings, the auditing, the validation, any kind of cross-cutting concern. And the funny thing is that you're actually not changing the original component model. You're just adding on top, on top, on top. And this is the open-close principle. In order to change the functionality or add the functionality to the component, you're not changing the original source code, but you're basically extending it. And sometimes I get the question, okay, I do have a decorators, I do have interceptors, which way to go? For me, it's usually decorator is something that you apply to the very known case when you have some component that you want to intercept and you want to change the behavior, but that's only applied to that particular component. Then I would go with the decorator. For the interceptors, I would go with for the very, very general purpose cross-cutting concern, like logging or performance counters or auditing or validation. Those doesn't depend on the specific component or specific service. Those I would be implementing as interceptors. And one of the most popular interceptor generation proxy is Castle. So you just give them the type and give the interface, and it will give you back the interceptor object. For instance, in the code base, it might look like following. So if I'm intercepting the particular method, what I can get here is, I can even inspect the given arguments. I can change the return value. I can do really fancy stuff. And the original component that was kind of invoked is not aware of this Matryoshka thingy. Just somebody called me. I'm performing my job, returning back the result, and somebody else might be intercepting that and changing or throwing the exceptions or doing some logging or doing some validations, etc. So this is this really open-close principle that you don't change the original code but add the functionality on top of that. So with the dependency injection, what it gives you is the loosely coupled code. So it's really easy that those components are not related with each other. You have to demand the dependencies if you require them. You have to just ask, I need those dependencies, and not trying to resolve by yourself. In order to be really successful, you have to understand what kind of IOC container you are using, which means that it would be really nice that you know all the features with loosely coupled scanning, with the open and closed generics and all that stuff, that you really leverage the features of the component, of the container. And also you have to look for the anti-patterns in the code base. And looking at the anti-pattern, I would really recommend you to be a Boy Scout, which really tries to refactor the code to be more maintainable, to be more loosely coupled, to be more readable. So with that one, thank you much for your time.